Hello 108 students, Mr. McHugh here with you. Coming back to work on 5.3 more with you here, page 2. Okay, I got off my soapbox there, but I'm on a new one now. And objective 3 deals with adding or subtraction polynomial functions. We're going to learn some notation here in this section here, and to kind of jumpstart this idea of functions, I thought it'd be kind of cute here. I get on the whiteboard, and this is me in my little smart car. I draw this. It's the little two-seater car. Mine's a little white one. You might have seen it around. And I love them so much, and I live in Garden City, and I go up and down Chinden Avenue, that I decide to take one of these used car lot sales, and I decide to start selling smart cars. Now, if you're going to go in business for yourself, this concept of what we call a profit function might be something you really want to focus on. And so how do you make profit in a business? Well, it's based on how much revenue you bring in, how much money you can sell a car for, and you bring all that money in, and what do you have to do? You have to pay your cost function, is how much money is going out. The difference between the two of them is your profit, or how much money you made. Okay, so this is a fairly simple idea, but it's fundamental to all businesses that are out there. So mathematicians could represent the profit function as P of X, and X represents the number of cars I'm going to sell, number of smart cars. Mine's just going to be smart cars. And I do some rough planning. I put a business plan together, and I'm going to go borrow some money from a bank, and I'm going to have my revenue function, which is how much money I bring in per car minus the cost per car. And I try to make this just kind of simple here. There's a lot of factors when you figure out a business, but let's just say I thought I could sell these cars for $15,000, and my costs associated with selling them, you've got overhead, you've got to pay the lot. I might have to pay for a admin person to help me out, aka my wife maybe. I might need a salesperson, but what if I could figure out and estimate that it's going to cost me $10,000 per car? And so if I said, well, how much profit would I make when I sell my first car? I would put 1 in for X, put 1 in for the function here, and I'd have 15,000 minus 10,000, and I would make $5,000 on my first car. If this was all linear, didn't change, how much money could I expect if I sell 5 cars? Say I could sell 5 cars in my first week. Well, I'd have 15 times 5 minus 10 times 5. My net result would be, this would be what, 75,000? That's not right. That's not right. Yeah, minus, yes it is, 50,000. And there you go. I would have $25,000 profit. Okay, let's just kind of get it warm up here. The big thing we want to focus on here is getting you guys comfortable with the notation of adding or subtracting functions. And so if you're going to sum of 2 functions, you can have the first function is f of x, and whatever it is, doesn't matter what it looks like, the polynomial, and you would add up the second one. It could be written with the notation of parentheses little f plus g, that comes from the functions, of x. This is the result name. Okay, the process is going to be to add the 2 functions inside. So you would say the sum of f and g of x. That means relative to the x variable. Okay, now how about the difference of 2 functions? That's what we did up here. If you have 2 functions that are function f and function g, if I want to write in a notation, I would write parentheses f minus g of x. How about up here? Here's a little challenge. How could I write this as a notation of a subtraction? I would write parentheses. I've got function r minus function c. I represent revenue minus costs, all relative to x. Oops, excuse me. Forgot the parentheses here. Of x. Okay, and of course now what that equals here is our profit of x up there. Okay, so all this fancy notation, you get some problems on here. You're going to do something we've already done, we've covered before. We've added or subtracted polynomials, that is combining like terms. So now don't let the notation mess with you at all. You're going to add 2 functions. They tell you the first function here in example 3a is x squared. Oops, nope, hold on. Cheyenne, no. x squared minus 3x plus 7. The second function is given to you as negative 3x squared minus 7x plus 7. They want you to add them up. What will the result be relative to x, the whole variable? So substitute the polynomials in for here. G of x is equal to this polynomial. Put them in, add them together because the notation tells you to add from right here, and combine like terms. 1x squared minus 3x squared turns into minus 2x squared. Minus 3x minus 7x is minus 10x. 7 plus 7 is 14. That is the net result of adding the two functions relative to the x variable. Now once you have that, and they want you to practice doing that way, usually your problems will be in two parts. Part A will ask you to write it relative to the general x variable. Now let's say, what if x has a specific value of 2? What would be the results of adding the two functions when x equals 2? Okay, the way that I'd like to see you do it is combine them up first. Now let x equal 2, substitute it in to the equation, and figure out the value. Now we've already got, you could go that way, you could do it individually, or you could do it algebraically here and combine like terms, come up with the result of 10x squared, then add the 2 in. Okay, that's the way the book wants it to go. This is the shortcut way up here. 2 squared is 4, 4 times 10 is 40, and that's your answer there for it. Okay, so we're moving along here now. We've done addition. I'm going to see you here on page 3. We'll talk about if you have subtraction, you would do simply subtract the two polynomials. Okay, but I'll see you on page 3 here in a little bit. Okay, bye.